Imagine looking out of your window, not at a city, not at clouds, but at an entire planet glowing beneath you. Recently, a NASA astronaut aboard the International Space Station captured a breathtaking sight from orbit. A massive green aurora stretching across Earth's atmosphere. At first glance, it looks like our planet is lighting up from within. But what causes this incredible phenomenon? Why does Earth suddenly glow green? And why do astronauts see auroras in a way most humans never will? Today, we're taking a journey hundreds of kilometers above Earth to witness one of the most beautiful views in the universe.
Welcome to the future of space exploration. Today, we're looking at the incredible missions mapping our entire universe. Are you ready to explore the
Most of us, experiencing the northern lights means standing in the freezing snow, looking up at colorful waves dancing across the night sky. But if you travel 400 kilometers straight up, that familiar vantage point completely disappears. Up here, the International Space Station circles the globe every 90 minutes, tearing through the vacuum of space at 28,000 kilometers per hour. Leaving the atmosphere changes how we perceive natural phenomena. Weather systems, clouds, and even light behave differently when viewed from the outside. Gravity keeps our human perspective incredibly small. To see the true scale of the forces shaping our planet, you have to look down from the void. NASA astronaut Nichole Ayers recently experienced this incredible shift in perspective firsthand. While aboard the station, she captured images of the Aurora as a giant glowing ring, visible all at once from the vacuum of space. This massive structure completely engulfs the polar regions, stretching across thousands of kilometers of the upper atmosphere. It leads to a central mystery. What kind of force is large enough and powerful enough to paint a glowing ring of fire around an entire planet? These photographs document the physical evidence of a violent, ongoing cosmic interaction. The origin of those lights begins nearly 150 million kilometers away, right on the surface of the sun. Our star is constantly boiling over, releasing intense streams of highly charged particles outward in all directions. We call this the solar wind. When an active solar storm hits, millions of tons of this material are ejected outward, hurtling through the vacuum of space directly toward Earth. If those particles were allowed to impact an unprotected planet directly, they would gradually strip away the atmosphere, boiling the oceans and leaving the surface barren. The only reason Earth survives this daily barrage is because that incoming stream crashes into an invisible planetary-scale wall.
Pause. How do creators find viral ideas? That's where vidIQ comes in. It helps optimize titles and find trends. Check out my link in the description. Now, let's get back to space.
Its own magnetic field. This shield safely deflects most of the lethal particles past the planet. But the defense has a weakness. Some charged solar material gets trapped along the magnetic lines, violently funneled down into the polar regions. As these trapped particles slam into oxygen and nitrogen atoms high up in our atmosphere, the high-speed impacts force a sudden release of energy. When oxygen atoms are excited by this solar impact, they shed that excess energy by emitting a brilliant bright green light. The serene glow of the aurora is actually the visible exhaust of a brutal high-energy war playing out in the upper atmosphere. Because of that intense atmospheric friction, researchers closely monitor the aurora. The size and intensity of these rings reveal the current state of space weather. If a particularly strong solar storm pushes past the magnetic lines, the resulting radiation can blind satellites in low Earth orbit, knocking out the communication and GPS networks we rely on every day. And the danger doesn't stop in orbit. Massive electromagnetic disturbances can plunge right through the atmosphere, surging directly into metal infrastructure on the ground. A severe enough strike could overload transformers, physically melting the hardware of global power grids and triggering widespread, long-term blackouts. Beyond its beauty, the aurora functions as a critical monitoring system for the infrastructure of our modern technological civilization. When you return to the vantage point of the space station and look back at the horizon, the reality of our situation becomes starkly clear. This impossibly thin layer of gas is the only thing separating a vibrant, breathing ecosystem from the lethal radiation of the cosmos. Nichole Ayers noted that watching those glowing curtains from orbit was a constant reminder that Earth is an active entity, reacting to its volatile environment. The Aurora remains the only definitive, visual proof we possess that our planet's invisible armor is actively holding the line. If you had just 1 minute aboard the International Space Station, what would you look at first?
From space, Earth doesn't look divided by countries, borders, or oceans. It simply looks alive. The glowing aurora captured by astronauts aboard the International Space Station is a reminder that our planet is constantly changing, constantly moving, and constantly protecting us from the harsh environment of space. Sometimes we spend so much time searching for wonders across the universe that we forget one incredible fact. The most beautiful world we've ever discovered is the one we already call home. This is Earth, seen from a perspective few humans will ever experience, and it's absolutely